Yeah, guys, I'm fine. Yes, guys, I'm fine. Thank you. Guys, shall we start? Dubai floods. Yes, we'll do this. See, guys, uh, I will give you a flow of how exactly we are going to cover the syllabus, guys, so that you will have some basic idea, okay? Because you might not feel there is some lagging of things and all. See, now I'm going to do soils. Okay, I'm going to do soils. In this, I am going to cover Indian soils as well. Okay, soils will do. And then in this, we are also going to see Indian soils. Right. After this, see, you know rainfall distribution in India, plus you're also aware about soils of India. Okay, rainfall distribution, you know, soils, you know, we will be able to study about Indian agriculture. Okay, Indian agriculture. World agriculture, little bit we have done with respect to what we call as, like, you know, uh, world climate. So here I'm going to do Indian agriculture part as well. And then I will start with bottoms of ocean topography, which is part of oceanography. After this, we will talk about temperature, salinity in the oceans. Okay, we are going to talk about, like, you know, waves, tides, and tsunamis. These aspects we are going to cover in detail. After that, I will teach you marine resources. So this is basic aspects when it comes to oceanography. Okay, this will be basics when it comes to oceanography. After this, we will check Indian physiography, Indian physiography. I have done Indian climate, so we'll look at drainage of India. Okay. See, guys, first let me tell you in India what all are there. Okay. In India, you will have space relations. Some aspects I'll teach you, but most of it will be covered in international relations. Second is physiography, which we have to deal still. Third is with respect to climate of India. Fourth is with respect to drainage of India, drainage systems or patterns of India. Then we have soils of India, which we will be doing today. Then we will have natural vegetation, which we have already completed. Apart from this, I also have to deal with resources in India, agriculture in India, industries in India, transportation in India, population and settlements. Now, these are the areas that I need to cover. In this, the major topics of climate, agriculture will be covered today, soils will be covered today, natural vegetation will be covered today. So the remaining is much more easier for us. Okay. Actually, here we have ocean currents, but I have done ocean currents as well. So this is the flow of geography for you. Okay. This is the flow of geography for you. Okay. From groundwater and all. Okay, groundwater features, karst topography and all. Yeah. Those I'll do every day, one topic I'll take and I'll do. Don't worry about it. Okay. So now let us talk about uh, Janvi. Apart from my class notes, if you can read NCRT, it is more than enough. Bhimrai, this is not a session on climatology. I can't teach you low pressure, high pressure in a class today, okay? Because I have to deal with other topics. So you can call me and ask if you have any specific doubts with respect to that. Everyone, please see. Let us talk about soils. You can write along with me, guys. You can write along. Okay. Guys, whenever we say soil pH, okay, whenever we say soil pH, okay, so that soil pH is normally 7. Aniket, we will be doing it in physiography, Aniket, don't worry. Soil pH on an average is 7. Here, I want you to know, when you add more fertilizers, soil will normally become alkaline. Okay. Whenever you add more fertilizers, soil will become alkaline or soil will become saline. Okay. So this is the first basic point that you must be aware. Let us say in the soil, whenever there is no bacterial activity, then soil will become acidic. Okay, soil will become acidic. Just remember, bacterial activity means whenever we put leaves on the soil, okay, plants, if you have, obviously the plant leaves and all will fall down. When it falls down, bacteria will come and consume them. When they consume them, they will convert it into humus. Okay, humus. And that humus is actually helpful for cultivation of crops. When there is no bacterial activity, there won't be no humus. There won't be humus. If there is no humus, the soil will become acidic. Okay, This concept, it must be clear to you. Now, soil basically means you may have three most important things: sand, silt, and clays. We have three basic things, that is sand, silt, and clay. Okay, sand, silt, and clay. And whenever I talk about, let us say, in the soil, 90% is sand, then I call it as sandy soil. Okay, and if I have clay, remember guys, chalk powder. Okay, chalk powder basically represents clay. Okay, chalk piece powder, if you take, that is similar to the clay. So if you have more clay, it will be called as clayey soil. Okay, it will be called as clayey soil. And if you have a mixture of sand, silt, and clay, okay, if you have a mixture of sand, silt, and clay, then it is called as loamy soil. Okay, then it is called as loamy soil. Mixture of sand, silt, and clay will be called as loamy soil. Only sand is there, we call sandy soil. Only clay is there, we call clayey soil. Mixture of sand, silt, and clay is basically called as loamy soil. Very, very important for you. Fine. And then please understand, soil will also have water, soil will also have air. Okay, soil will have water, soil will have air as well. And if I consider air, okay, you might have heard we normally do tilling of the soil. So whenever we do tilling of the soil, plowing the soil, at that time we normally do it so that air in the soil increases. It's very, very important to till the soil so that air increases. Right? These are some basic aspects. Now, you all read a very important thing about the soil, or about breakdown, called as weathering. Okay, now what exactly do you understand by weathering? Weathering basically means breakdown of rock in situ. Whenever we break the rock in situ, in that place, it will be called as weathering. Now, everyone, please look at this carefully for a while, please. Okay, please look at this carefully for a while. Later, you people can draw this. You won't be given prize if you draw along with me. Okay, so please wait, understand, and then you do. See, guys, at the bottom, let me say you have a rock. Okay, parent rock is there. Fine, parent rock will be there. Now, above the rock, above the rock, let us all assume that you have freshly weathered rocks. Okay, so you may have freshly weathered rocks. Guys, roots of the trees might have gone down. Okay, roots of the trees might have gone down and they have broken these rocks, and it will form freshly weathered rocks. Okay, so this is basically called as freshly weathered rocks. Now, if I consider an ideal soil, if I consider an ideal soil, I may observe a mixture of sand, silt, and clay. Okay, I will observe a mixture of sand, silt, and clay. As I told you, clay is very, very small, sand is little thicker, and in between will be silt. Okay, clay is very small, sand is little thick, in between part will be called as silt. Now, here I have sand, silt, and clay. Okay. Now, what will happen is, please see everyone. Let us say, because of rainfall, water will flow like this downwards. Okay. Because of rainfall, water will flow down like this. It will come. Now, when water flows down, what is going to happen? All the minerals, see everyone, all the minerals from above, all the minerals from above will come and accumulate in this layer. Okay, please understand. All the minerals, humus, salts, whichever is there above, that will come and it will accumulate in this layer. So, in this layer, what is happening? There will be accumulation of minerals. Accumulation of minerals, salts. Okay, accumulation of minerals, salts, and humus. Right. So what is happening, guys? Everything is coming and accumulating in this layer. Okay. Please understand the process of accumulation. If anything is accumulating, the process of accumulation is called as eluviations. The process of accumulation is called as eluviation. So, what is eluviation? Whenever there is rainfall, water will fall on the soil and water will go down. When water is going down, what is water doing? Water is trying to remove everything in the soil, and once it is removing everything, it will come and accumulate in one layer of the soil. Everything will accumulate in one layer of the soil. That accumulation is called as eluviations. Okay, that accumulation is called as eluviation. Now you tell me, due to rainfall, if everything is removed from this layers, okay, if everything is removed from this layers, so what will happen in these layers? There will be removal of minerals, correct? In one layer accumulation is occurring, so in another layer there is removal of minerals, there is removal of salts, and there is removal of humus content. Okay, So there is removal of salts, removal of humus, and there is removal of minerals. So remember, whenever there is removal, when something is removed, we use the term alluviation. Alluviation. Okay. Alluviated layer. Alluviation means removal. Alluviation means accumulation. So what is happening in this part? Everything is getting removed. Okay. So at the bottom I have parent rock. Just above that I have freshly weathered rocks. Above the freshly weathered rocks, I will have sand, silt, and clay. Okay, sand, silt, and clay. And now, when I look at this particular thing, okay, so because of rainfall, everything is coming and accumulating in this layer. Okay, and above that, everything is being removed. Accumulation layer is called alluviation. Removal layer is called as alluviation. But remember, guys, rainfall does not occur every day, correct? Rainfall does not occur every day. So let us say now there is no rain at all. Then what is going to happen? There will be topmost layer of the soil, guys. Topmost layer of the soil, which is always in contact with external environment. So on the soil, one layer everything is removed. Now rainfall is not occurring. Let us say in India, as of now, rainfall is not occurring. Now when we don't have rainfall, what is going to happen? You will normally observe that in this layer, what is this layer called? Topsoil layer. Okay. In this topsoil layer, let us say some leaves will fall down. Okay. Some leaves will fall down. Is there possibility of leaves becoming humus? Yes. We throw food into it. Okay. Then what is going to happen? Soil erosion may happen. Top soil may be removed. Or from other place, soil may come and deposit. So, topsoil, what is the characteristic of topsoil? It would contain, okay, topsoil would contain, there would be minerals. There would be minerals. There would be salts. There would be humus. Okay. Everything will come and settle on the topsoil. Then rainfall will occur. Rainfall will take it down. Okay. First, everything should come on the topsoil. Rainfall will occur. Rainfall will take it down. So, basically, the topsoil is called as A layer. Alluviated layer is called E layer. Alluviated layer is called B layer. Freshly weathered rock is known as C layer. Okay. A layer, E layer, B layer, C layer, R. R is parent rock. You see, I'll repeat. A layer is actually topsoil layer. E layer is alluviated layer. B layer, accumulated layer. Okay, C layer, freshly weathered rocks. R is parent rock. Okay, guys, remember every area soil will be different. Okay, every area soil will be different. In some areas, all the layers may be there. In some areas, only one layer is there. In some areas, no soil at all, only barren rock will be there. But an ideal soil, okay, if I take an ideal soil, this is the case. This is what we expect from an ideal soil. Now everyone, you see, on top of A layer, we may have something called as organic. It is called organic layer, which is called as O layer. Okay, organic layer is called as O layer. Okay, what exactly is organic layer? Okay, let us see like this. Uh, Let me say you throw food on the road. Okay, so after 1 or 2 days, the food won't be there. Animals might have eaten, or you take the other case, bacteria may act on it, and bacteria will degrade it slowly, and it will become humus content. Okay, so leaves of the trees may fall. Okay, animals may poop. So because of anything, if some organic matter is falling on the soil, that layer is called as organic layer. So we normally give it as O, A, E, B, C, R. They will give you these alphabets and ask you to arrange in order also. The topmost layer is O layer, below is A, E, B, C, R. That order is also important. And if they ask you to talk about soil horizons, okay, if they ask you to talk about soil horizon, soil profiles, it is very, very important for you to see this. 5 marks or 10 marks, if they ask you soil horizon or profile, you should draw this. Okay, now I'll give you 2 minutes. Please draw this. See guys, Sony weathering we said breakdown of rock in that place. That's why important to attend classes before. Yeah, Lakshmi, when we talk about yeah, Lakshmi, when we talk about Alleviation. Alleviation basically means everything is removed. When water goes down, everything is removed. So in layers where everything is removed, it is called alleviated. In layers where everything is accumulated, it is called as alleviated. Okay. Yes, Sushmit. Yes, Anjali. Organic layer, organic layer Vinay, uh, in B layer, everything gets accumulated. Okay, it won't go down. If it goes down, even that will be removed. Huh. Organic layer, guys, basically means wherever, like microorganism decomposable matter will fall. Organic layer basically means wherever decomposed or decomposable matter will fall. For example, leaves may be there. Okay, what do you call as animal waste may be there. All those, when it falls down, that is called as organic layer. Okay, I hope everyone drew this. I will go to next page. Ma'am, freshly weathered rocks means just above parent rocks, because of trees penetrating down, they may break the rocks. Okay, so this will be there will be cracks in the rocks called as freshly weathered rocks. Over a period of time, these freshly weathered rocks will become sand, silt, and clay. Yeah. Biohumus layer is also O layer height. Gayatri, as I told you, ideal condition is this. but anywhere anything can happen. Okay, ideal condition is this, but anywhere anything can happen. Thickness of the soil varies from place to place. On a mountain, thickness will be different, but on a plain area, thickness will be different. Okay, you write along with me. O layer or organic layer. This is mostly present when decomposable organic matter is deposited. It may have undecomposed organic layer. Guys, undecomposed organic layer basically means if food is fallen today, you can see that. Till the time you see that, that will be undecomposed. Once it is gone, it will form decomposed. It may have undecomposed organic layer and decomposed organic layer. See guys, this keeps on changing. Today, if I throw the food, it will be undecomposed. Later, it will become decomposed. Only. Next, I have a layer or topsoil layer. Topsoil layer. Okay. This is topmost layer of the soil and it is in constant contact with external environment. It is in constant contact with external environment. It receives rainwater, air, soil, minerals, humus, etc. Everything will be there in this layer first. Later it will go down. E layer, elevated layer. E layer is also known as elevated layer. Due to rainfall, water percolates. Percolates means moving down. Water percolates downwards and remove minerals, salts, and humus. As everything is removed, it will be in light color. As everything is removed, it will be in light color. See guys, when everything accumulates, soil will become dark color. Just remember, if humus is there, soil will be in dark color. If humus is not there, soil will be in light color. B layer or eluviated layer. Okay, B layer is also called as eluviated layer. In this layer, we observe we observe accumulation of minerals, salts, and humus. It is normally dark in color. Is normally dark in color. Next is C layer. C layer. It is freshly weathered rocks layer, and in this there will be cracks and gaps between the rocks. As you see guys, as you see here, you will have lot of gaps. Next, R layer. It is the bottommost layer where it will be bottommost layer where parent rock from which soil is formed. Soil is formed. Guys, I'll move to the next one. This is about soil layers or soil profiles. The next easiest one is about factors that affect soil formation. Okay, factors that affect soil formation. Is this is very very important for you. Okay, it is present in 7th standard NCRT book also. Now, the first most important factor is parent rock. Okay, parent rock. So let me consider parent rock. What are the two parent rocks that I have? Let me take the case of basalt. Okay, what is basalt? Basalt is extrusive igneous rock. And let us take the case of granite. Granite is intrusive igneous rock. Okay, one is formed inside the earth, another one is formed outside the earth. Now, uh, let me say this, as it is in extrusive, it normally have fine grains. Okay, particle size is very very small, whereas when you look at granite, it is coarse grains. Granite is basically coarse grain. Basalt is basically fine grain. Okay, so we have two things: basalt, which is fine grain; granite, which is coarse grain. Okay, coarse grain basically means the size of this is huge. It will be like this, but here it will be very 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 small. Hmm? Hmm. Now let us say there will be weathering of both. Okay, weathering of both basalt and granite will occur. Now you see, I'll take chalk powder. Basalt will be like chalk powder or chalk piece. I'll keep on hitting the chalk piece. Can I say, like, if I keep hitting, the chalk piece will become clay. Okay, very, very thin. Anytime you take chalk powder and try to see, you don't know how many particles are there. You can't separate one from the other. So, what is going to happen? Basalt will give me, basalt will give me what? Basalt will give me clayey soil. Basalt always gives me clayey soil. Whereas when I take granite, okay, granite if I take, see, if I hit more, it will become clay. If I hit less, it will become sand. If I hit in between, okay, if I hit very less, sand. If I hit more, clay. Okay, if I keep on hitting it, it will become clay. If I hit in between, it will be loamy. That is mixture of sand, silt, and clay. So what am I getting? If I take granite, I may get sandy soil. I may get loamy soil. I may get clayey soil. Okay. So what I'm trying to tell, breaking means weathering. Okay. Granite, if I take a big one and if I hit them, it may become sand, it may become clay, or it may become sand, silt, and clay. But when I take a chalk piece and when I hit any time, it will always be clayey. So, whether the soil is clayey soil or the soil is sand, silt, and clay, depends upon the type of parent rock. Okay, second, let me say I have iron content in the soil or in the rock. Okay, if rock has iron content, normally iron will undergo rusting, chemical weathering, rust will occur. As iron becomes rust, it will become red, right? It may be orange, it may be yellow, sometimes it may be black as well. So the soil color also depends upon the parent rock. Okay, so what do we say? Is parent rock important? Yes. Parent rock, it determines texture of the soil. It determines texture of the soil. That means sand, silt and clay. Mineral composition of the soil. Okay, so parent rock is very, very important for us. First factor which determines it is parent rock. Okay, I'll give you 30 seconds. Please note if you have not written. Okay. After parent rock, the second most important thing is with respect to what we call as rainfalls. Rainfall. Rainfall plays a very, very important role. Why? Let me tell you. Okay. Now, you see, I have Rajasthan. Okay. Near Rajasthan, I normally have granite rocks. Chota Nagpur plateau of India almost have granite rocks. Okay. And if we take Western Ghats of India, it also has granite rocks. So I'm taking same granite rocks. Okay. So one, I'm talking about Rajasthan. Another one, I'm talking about Chota Nagpur plateau. Third, I'm talking about Western Ghats. So I have three things, three areas. See guys, Western Ghats, if you recollect rainfall chapter, it comes under wet climate. That means very heavy rainfall. Rajasthan comes under arid climate. Rajasthan comes under arid climate. Chota Nagpur plateau comes under moist climate. Okay. So that means Western Ghats rainfall is very high. Okay. Rajasthan rainfall is very less. Chota Nagpur plateau in between. Now, if I go to Rajasthan and see, normally I observe sandy soil. Rajasthan, I will observe sandy soil. If I go to Chota Nagpur plateau and check, I will get loamy soil. Okay, loamy soil. But if I go to Western Ghats and check, I will get clayey soil. Guys, remember, more rainfall, rocks will break down more. Less rainfall, rocks will break down less. So if I go with that point, granitic rocks are broken down into clay in Western Ghats. We already saw Western Ghats will have very heavy rainfall. And when I talk about Rajasthan, it has arid climate, and because of which rainfall will be less and you will have sand. When I talk about Chota Nagpur Plateau, rainfall is in between. So I will have loamy soil, sand, silt, and clay. So can I say rainfall determines what type of soil will be there? Yes. Second is, let us take uh, Rajasthan. Okay, Rajasthan region. Rainfall is less. Correct? Rainfall is less. So what will happen? There is no much water going down. Chota Nagpur Plateau rainfall is in between. So what will happen? You will have water coming till B layer. Okay. So Chota Nagpur Plateau, so water will come till B layer. But let me tell you, if you have very heavy rainfall, Western Ghats and all, very heavy rainfall, what is going to happen? Water will come down till here. Water will come down till here. Can I say water is not even accumulating in B layer, but it is going below that? Okay, it is not near B layer, but it is going below that. Below that, till where it is going? It is going till C layer. Below that, till where it is going? It is going till C layer. That means the water will go down, it will remove whatever is there in the soil, and it will leach completely. This process is called as what? Leaching. If you recollect, I told you, in Amazon basin, Congo basin, as there is very heavy rainfall, water will go down, water will remove everything, and it will leach the soil. As soil is leached, you will not have fertility in the soil. And as fertility is not there, we normally see that the shifting cultivation occurs. This is the reason. Now, guess what is going to happen? If there is no accumulation, everything is removed, B layer won't be there. There won't be B layer at all. Okay, please see this. As I told you, this is ideal condition. In different areas, different condition exists. So more rainfall, very high rainfall, B layer is not there at all. Less rainfall, E layer is less. Okay, E layer is less. Why? Because as water is less, removal will be less. Okay, don't get into these technicalities, not required for your exams, but you must have clarity about what acts as water. Okay, so guys, two things depend upon rainfall: soil texture and fertility of the soil. And fertility of the soil depends on rainfall. High rainfall areas will have clayey soil, and soil will be leached. Soil will be leached. Low rainfall areas will have sandy soil. So this is the impact of rainfall. Okay, this is the impact of rainfall. Next is third factor. First is parent rock. Second is rainfall. Third is temperature. Okay, guys, you see, you have soil, high temperature, low temperature. Guys, in low temperature areas, snow will be there. In high temperature areas, rainfall will be there. Okay, low temperature areas, snow will be there. High temperature areas, rainfall will be there. So now what happens? High temperature means there will be bacterial activity. High temperature means there will be bacterial activity. Low temperature basically means no bacterial activity. There is no bacterial activity. As there is no bacterial activity, guys, what is going to happen? In low temperature areas, the soil will be acidic, right? In high temperature areas, there is possibility of soil to be alkaline. Okay, soil almost turns alkaline in high temperature. Soil almost will be acidic in low temperature. Second, guys, our body itself you consider, okay. If temperature is more, what is going to happen? We all start sweating. Okay, we all start sweating. So when sweat comes, even our body will become alkaline, because all salts come and accumulate on our body. Similarly, soil also if you take, when there is high temperature, almost all the salts that are there below the soil will come up and they will accumulate. I repeat, the way our body sweats, when there is more temperature, whatever salts, minerals have gone down, they would come up and it would accumulate. Same as our body, soil also gets salts accumulating on the surface. That's why in Punjab, Haryana, Uttar Pradesh and other areas where more amount of fertilizers are added, what is going to happen? All the water will take the fertilizers down. But when there is very high temperature, everything comes up and it accumulates on the surface. So that will form saline soils, alkaline soils, we call it. So what is happening here? High temperature normally leads to upward translocation. I will teach you what exactly upward translocation is, guys. Upward translocation of minerals and salts and leads to alkaline soils. Low temperature normally does not allow bacterial activity and leads to acidic soil. Acidic soil. Because this is normally present in coniferous forest area. This is normally present in India's Punjab, Haryana, Uttar Pradesh area. Okay. Next is 30 seconds if you want to see anything. Fourth is relief or slope. Relief or slope. See, guys, this will be called as steep slope. This will be called as gentle slope. Okay. You see, steep slope, what is going to happen? Soil will come down. Gentle slope, what is going to happen? Soil will accumulate. So basically, steep slope means less thickness of the soil. Gentle slope, more thickness of the soil. Gentle slope, more thickness. Steep slope, less thickness of the soil. Okay. So can you people write? Thickness of the soil depends on the slope. Steep slope leads to less thickness and gentle slope leads to more thickness. Gentle slope leads to more thickness. This is very, very important. Next is 30 seconds is write fast. Fifth, guys, time. See, guys, breaking down of rocks will take a lot of time. It's not easy for a rock to become sand, silt, or clay. To form 1 centimeter thick soil, it will take 500 years, it seems. That means more time, more thickness, less time, less thickness of the soil. Very simple. Okay, more time, more thickness of the soil, less time, less thickness of the soil. So what is the time that you talk about? It would take 500 years to form 1 centimeter thick soil. So as time increases, thickness of the soil also increases. Thickness of the soil also increases. This is very, very important. Sixth factor, biological activity. That means presence of living organisms. As you are aware, what does trees do? Trees will go down, break the rocks. Okay, can I say biological weathering is also important for breakdown of rocks in situ? Okay, so what are we talking about? When we talk about biological activity, whether you want to form humus, whether you want to break down the rocks, living organisms are very, very important. Okay, so biological activity is very, very important. Biological activity for biological weathering, humus formation, etc. Biological activity is important. Okay, see guys, 10 mark question. Okay, what are the factors which lead to formation of soil? Factors which lead to formation of soil. Factors which affect formation of soil. Shweta, alkaline is also not good, acidic is also not good. pH value has to be 0, then only it is good. Yes, Madhupuran, you will not have organic layer in Arctic and Antarctic. Alkaline means saline. Leached means when everything is removed. Kamalpal, alluvial soil will have highest salinity, highest fertility. Manpreet, there won't be humus content, Manpreet. That's why sandy soil is not productive. Yes, Gayatri. Sushmit, Western Ghats, not Western Ghats, Deccan Plateau is made up of basaltic. In Chota Nagpur Plateau, if you had arid, that means it would have got sandy soil. Yeah. Pooja, if flooding happens, water will go through sea layer. Okay. Kennedy, primary rock basically means you are talking only about igneous rock. Okay. But here I am talking about rock, all types of rock. Sedimentary, metamorphic, igneous, everything. I took examples only of igneous. Aniket, how do we define soil profile? Soil is arranged in different layers, and these are the layers. That's it. Abhishek, water and soil almost will have same pH, so that's fine. Yes, Vinay, you're right. Okay. Sea layer. Yes, Vinay, you're right. Everyone. Let us talk about next topics. Soil forming processes. Guys, do you know if you take geography optional, all these 85 to 90 hours of lectures will be almost repetitive. Uh, Apart from this, you may have to study few chapters. Depth is almost same. Those people who are asking, depth is almost same. I will teach same topics: soil profile, soil horizon, everything remains same. Okay, now soil forming processes. First one, we need to talk about addition. Addition. Please understand, when rainfall occurs, water is added to the soil. Correct? When rainfall occurs, water is added to the soil. So, what is addition? From outside, if anything is added to the soil, it is called as addition. Let us take a case. Rainfall will occur, water is added. Let us say leaves, something will fall, organic matter is added. Okay, and let me say soil is eroded at one place. it is deposited at another place. Okay, so if soil is deposited, let me say this is a soil layer, some soil came and got deposited here. If soil is deposited here, then it will be called as addition. Okay, see what is addition? Rainwater is addition, air is addition, fertilizers if you add, it is addition, organic matter if you add, it is addition. Okay, what do you call it as, like, soil eroded at one place, if it comes and falls here, that is also addition. Let us say, like, from Himalayas rivers will flow. When the rivers are flowing, they will carry sediments with them, and when they come to the Ganga basin, they will deposit the sediments. So in Ganga basin, soil is added. Okay, in Ganga basin, soil is added. That is called as what? Addition. Okay, see this, everyone. What is addition? When anything is added to soil externally, then it is addition. Example, organic content, water, fertilizers, soil deposition. All these processes comes under addition. Second process is called as removal. Okay. See guys, when there is soil erosion, that means, let us say I have like this. Okay, I have like this. Rainfall fell on this, and the surface of the soil is removed. That is called as removal. Okay, so soil erosion will be called as removal. Let me say there is heavy rainfall. So water will go down. I am talking about two processes. Okay, heavy rainfall, surface soil is removed, it is called erosion. Water will go down. Okay, water keeps going down, and water will reach sea layer, and then everything is removed from the soil. That is called leaching. Okay, removal processes includes erosion, it also includes leaching. Okay, third, you see guys, in coniferous forest areas, normally from the trees, guys, some chemicals are released, it seems. Chemicals are released, and these chemicals will remove minerals and salts, and that process is known as cheluviation. Remember, rainfall, if it is removing everything, we call it leaching. If trees are there, the chemicals coming from the trees will remove everything. That process is called as cheluviation. Okay, so what do you write? When anything is removed from all the layers of the soil, all the layers of the soil, then it is called removal process. Example, soil erosion removes topsoil layer. Topsoil layer. Topsoil layer is basically removed by soil erosion. Okay. 30 seconds, please finish. Second example, in heavy rainfall areas, water percolates down and remove minerals and salts known as leaching. Remove minerals and salts known as leaching. In forest areas, the chemicals released from the trees would remove minerals and salts known as cheluviation. So guys, first process is called as addition. Second process is called as removal. Third process is known as transformation. Guys. Transformation. What is transformation, guys? So change from one form to another. Okay, let me say I put organic matter, leaves I put, it became humus. Iron is there, iron became rust, ferrous oxide. Okay, ferrous minerals became ferrous oxide. That is, when something changes from one form to another form, it is called as transformation. Okay, you're right. When there is change from one form to another, then it is known as transformation. Example, organic matter is converted into humus. Ferrous minerals are converted into rust. This is called as what? Transformation. Okay, next guys. Fourth is translocation. See guys, removal means it is completely removed from all the layers of the soil. Removal means it is completely removed from all the layers of the soil. Then it is called as removal. Okay. But in the soil, O layer is there, A layer is there, E layer is there, B layer is there. Yes. Now let us say from one layer, if it goes to another layer and accumulates. Okay. So from above layer, it is going to below layer, or from below layer, it is coming to above layer. That is basically called as translocation. So what is translocation? Translocation is movement of minerals and salts from one layer to another layer. That is called as translocation. Okay, so please write what is translocation. When there is movement of minerals and salts from one layer to another layer within the soil, it is not completely removed from the soil, does not completely removed from the soil. There are two types of translocation, guys. One is downward translocation. Downward translocation. Guys, what is the meaning of this? When humus content will move from above layers to below layers. When something moves from above layers to below layers, it is called as downward translocation. What is the above layer? What is the order? O, A, E, B, C, R. Correct? So let us say organic content is in O layer. From O layer, if it comes to A layer, okay, or from elevated layer, removal layer, if it goes to elevated, accumulated layer, that is from E to B, it is called as what? Downward translocation. So when from above layers, minerals and salts move to next layer, it will be called as downward translocation. You see, whenever humus minerals and salts will move from above layers to below layers within the soil. Example, example, humus content, humus content from O layer translocates to A layer. Minerals, salts, and humus from E layer translocates to B layer. That is called as downward translocation. Downward translocation. Now guys, as I told you, let me take my skin, okay? When sun's rays will fall from inside my body, salts and water comes on the surface. Sweat. Water will evaporate, salts will be left behind. Similarly, if you take soil, so let us take this as a soil layer. When sun's rays will fall, high temperature, sun's rays will fall. All the water and minerals which are there inside the soil will come up to the surface. Okay. From the surface, water is evaporated, salts are left behind. So here, salts, minerals, water from below layers are coming above. Okay, are coming above. Water is evaporated, water is removed, whereas salts get accumulated. So that is, there is translocation of salts and minerals from B layer to surface layer, that is A layer. That is called as upward translocation. Upward translocation. So the way sweat comes through capillary action. Okay, if you want to know what is capillary action, you can do research on it, guys. Upward translocation. Due to, guys, capillary action is the way sweat comes out of the body. It is the same way through which, like, salts also come. I would request, please do research on that. If I explain capillary action, then entire class will go in doubts of capillary action itself. So due to capillary action, because that is not important here. Okay, due to capillary action, salts and minerals from B layer would accumulate near the earth surface. Near the Earth's surface and leads to alkaline or saline soil. Simran, cheluviation means chemicals of the plants is removing the minerals downward. Erosion means, remember guys, erosion means top soil is removed. So if something is removed like this, soil is there, something is removed like this is erosion. If water goes down and removes, it is called leaching. If chemicals of the plants go down and remove, it is called as cheluviation. Yes, Sonal. Yeah, guys, take break. 6:50 will meet. Yeah, Anjali, if you can draw 3-4 questions that, like, 3-4 diagrams, then it's the best. Everyone done with this? Now, we'll see two processes, guys. Soil erosion and soil conservation. Soil erosion, soil conservation. These two are very, very important for us. Now, in this, guys, soil erosion. Please understand, soil erosion is not about leaching. It is removal of the topsoil. Is the video proper, guys? Just a minute. Okay. Everyone, soil erosion. I want you to write heading as soil erosion. Six. The first one is splash erosion. Splash erosion basically means when rainfall will occur. Okay, you see, from such a great height, when raindrop will fall on the soil, what is going to happen? Wherever it falls in that area, some amount of soil, loose soil, will be removed. Like this. See the picture? That is basically called as splash erosion. I want you to write splash erosion when erosion of soil occur due to impact of rain water. Basically, it is said that it is the first stage of erosion. First stage of erosion called splash erosion. Second, you see, you will get like this. Due to splash erosion, you will get like this. Next, you see this sheet erosion. Sheet erosion. Everyone, check here, guys. Can you see this part? In this, can you see some layer of the soil is being removed? So, what do we say? When some layers of the soil is removed, then it is sheet erosion. And guys, this is second stage. This is second stage. So this is also very, very important for you. Sheet erosion. First is splash erosion. Second is sheet erosion. Now you see, this is how sheet erosion looks like. Okay, some layers of it on top will be removed. Now what happens? This would accumulate. Okay, the sheet would accumulate vertically downward. You see here, vertically downward. Then it is called as rill erosion. I showed you rills in fluvial also. So first is splash, second is sheet, rill. When there is vertical erosion of soil, when there is vertical erosion of soil, then it is rill erosion. Okay. Now you see these rills may accumulate. Okay. So when rills accumulate, you get gully erosion. You see here? These are gullies. Gully erosion. So remember, rainwater splash. Okay. When splash accumulate, it will form sheet. When sheet is deeper, it will be rills. When rills accumulate, it form gully. Gully erosion. When rills accumulate, it will form gully. Guys, when gullies accumulate, it would form ravines or badland topography. Badland topography. Example, Chambal ravines. Madhya Pradesh area, Chambal river is there. There you will have Chambal ravines. You see guys, this is gully erosion. Now, as you are aware, when the river meanders, see here, when the river meanders, can you see this particular part? It is eroded. See like this. So this is basically called as what? Stream bank erosion. Stream bank erosion. What is stream bank erosion? During meandering of rivers, the streams would erode the banks of the river. When river is moving like this, wherever it erodes, that is called as stream bank erosion. See, guys, coastal erosion. Okay. So what is coastal erosion? Near coastal areas, there will be soil erosion. Due to waves, okay? Add that. Soil erosion due to waves. Like this. See guys, this is landslide erosion. During landslides, a layer of the soil is eroded, called as landslide erosion. This next, wind erosion. Okay, guys, remember, if more trees are there, wind erosion doesn't occur. So normally trees are less in arid and semi-arid areas, right? So wherever rainfall is less, trees will be less. So in arid and semi-arid areas, wind action would lead to erosion, called as wind erosion. Normally, open field, hundreds of acres of land, trees are not there. So in such areas, wind erosion is very common. You see here? Can you see these lines? They are actually removed by wind erosion. Okay, next guys. See guys, tillage erosion. That means whenever you till the land, okay, whenever you till the land, you are loosening the soil. And whenever soil is loosened, it will be exposed to erosion. So whether rainfall will occur, it will be removed, wind will be there, it will be removed. Okay? Tillage erosion basically means due to tilling of the land. Due to tilling of the land, we normally observe that soil is loosened and is exposed to erosion. So this is called as tillage erosion. Yes, next, You write soil conservation. Soil conservation. You saw soil erosion. Now we are seeing soil conservation. Yes. So now guys, soil conservation. Remember, I have a piece of agricultural land. Now when it is exposed to wind erosion, all the soil will be removed. All the soil will be removed. But let me say, I will put trees here. I will put trees here like this. So what is going to happen? Trees will prevent wind action and it will protect this area. See here, like this. Now due to this, wind speed reduces. As wind speed reduces, erosion reduces. Okay, erosion reduces. So to prevent wind erosion, shelter belts are normally built. To prevent wind erosion, shelter belts are normally built. So what is shelter belt? Growing trees along agricultural land to prevent wind action. Growing trees along agricultural land to prevent wind action. That is called as what? Shelter belts. Second is strip farming. Okay, you see this. I'll tell you. Now, I will grow same crops everywhere. Okay, only one crop. I have 100 acres land. Only one crop I am growing. So what is going to happen? Very simple. What is going to happen? Very simple. 100 acres wheat is grown. Now what I'll do? Harvesting time, all 100 acres I will cut. All 100 acres I will cut. Land is empty. Land is exposed. Okay, land is exposed. No, what I'll do? One, I'll go for corn. Another one, I'll go for oats. Another one, I'll go for hay. Okay. One will take 4 months. Second one will take 5 months. Third one will take 6 months. After 4 months, what will I do? I will cut this. Okay, I will cut this after 4 months. Now, can I say land is still covered by other crops? Now, what is going to happen? I will grow a new crop. I will grow a new crop. And by that time, fifth month will come, I will cut this. Then I will grow new crop. 6 month will come, I will cut this. I will grow new crop. So can I say at any point of time, one crop will always be there? That is called as strip farming. So what exactly is strip farming? When there is monoculture, that means single crop cultivation, monoculture, then entire agricultural land is cleared at the same time. At the same time. And land is exposed for erosion. Land is cleared or harvested. When different crops are grown, when different crops are grown, then at least one crop will be there on the surface and prevents erosion. Prevents erosion. Yes, one is shelter beds, second one is strip farming. Strip farming, like this. Third is, you see, basic understanding of the farmers is, if slope is like this, okay, gentle slope is not steep slope, gentle slope. So what people used to do, they used to till the land like this. Let us say I will till the land like this. Why? Because if I add water here, water will go down easily, right? And it will help in cultivation. But later I realized that when water goes in slope like this, erosion is more. Why? Because speed will be more. So what I decided, I should not plow the land like this. If I have to prevent erosion, I need to till the land horizontally. That means if slope is like this, I should till the land perpendicular to the slope. If I till the land perpendicular to the slope, it is called as contour tillage or plowing. What is it? When there is slope in the agricultural land, then we need to till the land perpendicular to the slope. Then we need to till the land perpendicular to the slope. This is called as contour tillage or plowing. Contour plowing. like this. Next, please see here. When I have steep slope, gentle slope, contour tillage is fine. Steep slope, okay. Even if I till the land like this, water will still flow faster. So what should I do? To reduce it, I should normally go for step cultivation. You see, step like cultivation. So what will happen if you have step like cultivation? Speed of the water reduces. Now the step like cultivation is called as terrace farming. Step like cultivation is called as terrace farming. See, terrace farming. When there is steep slope, then the slope is converted into step like feature known as terrace farming. And please remember, guys, when you have like the steps like this, okay, here I will grow plants, here I will grow plants, or here I will put a barricade like this so that water accumulates here. Even though if I have step like, I will put some barricade so that slope is reduced. See, like this. This is what we normally call it as soil conservation. We call this as soil conservation. So terrace is like steep slopes, ma. See, ma. Slope is like this. I am slope is like this. I am cutting the land. Literally, I am cutting the land and making it steps like. That is terrace farming. I am not cutting the land, just I am tilling the land. That means I am tilling the land perpendicular. That is called as contour plowing. Gaps will be given, Anjali. Fertility is always a problem when you keep on cultivating different crops. But just imagine if I can grow leguminous crops and all, can it improve fertility? Shelter belts, Aditya. Shelter belts. Yes, Lakshmi. Done? Done, everyone? It's just 2 minutes. Open your atlas. I'll join. Okay. See soils map. I will join. Yes, yes. Now, let us see Indian soils. Distribution of soils in India. Ninth standard, 11th standard, India physical. You need to read this. Indian soils. Everyone, everyone. First, most important soil is alluvial soils. Alluvial soil. So, yes, soil deposited by river is called as alluvial soil. Soil deposited by wind. Okay, you see, soil deposited by river is always called as alluvial soil. Soil which comes and falls due to gravity is called as colluvial soil. Okay, soil deposited by glaciers is called as till, glacial till. Okay, alluvial soil, colluvial soil, glacial till. These are different names. Okay. Now, no. Wind and gravity are different. Wind, it is normally known as, sorry, wind is normally known as aeolian deposits. Now, we are talking about alluvial soil in India. Okay. So, wherever rivers flow, wherever rivers flow, we will have alluvial soils. Wherever rivers flow, we will have alluvial soil. Now in India, alluvial soil is present in two areas. Two areas alluvial soil is present. One is your Gangetic plains. Okay, that is Ganga Ganga Brahmaputra plains. Gangetic plains, also known as Indo Ganga Brahmaputra plains. So near the plains, you will normally have alluvial soil deposits. Why? Himalayan rivers will flow and they will deposit sediments. Okay, Himalayan rivers will flow and they will deposit the sediments. Second, you will also have near the deltas. So deltas basically are present in east coast of India. East coast of India. Okay. So as deltas are present in east coast of India, you will have alluvial soil in east coast of India. You also have the deltas present near Gujarat coastways. Narmada, Tapi and all, they flow near Gujarat coast. So they also have alluvial soil deposits. So in India, alluvial soil deposits are present in Indo-Ganga Brahmaputra plains. They are also present in east coast of India and Gujarat coast. Now, everyone, for 2 minutes, just look at this. Later, you can draw this. Okay. See, guys, one is Indo-Australian plate. Indo-Australian plate. Another one is Eurasian plate. I'm talking about continent convergence. See, guys, this is my Indo-Australian plate. This is my Eurasian plate. I'll have trans, greater, lesser, Shivaliks. Okay. So basically, this is my Himalayas. This is my Himalayas. And guess you are aware that whenever land is down, we call it as geosyncline. So this is called as Gangetic geosyncline. Called as Gangetic geosyncline. And here you will have peninsular plateau. Okay. See, this peninsular plateau is made up of hard rocks, whereas Himalayas are made up of soft rocks. Okay, peninsular plateau is made up of hard rocks. Himalayas are made up of soft rocks. So basically, Himalayas would carry more sediments compared to peninsular plateau. Okay, Himalayas would carry more sediments compared to peninsular plateau. Please, for 2 minutes, observe. Later, you write. Else, I keep seeing repeatedly whenever I explain while drawing diagrams, the doubts are more because you are not listening. Okay, please, guys, listen for some time. Now, you see, guys, let me take a glass of water. Okay, glass of water, and let me add sand into it. Sand into it. As soon as I add sand into it, what will happen? All bigger particles, big particles will settle at the bottom. Second, smaller particles will settle. And third, some particles will be floating. So, whenever we add sand into the water, first thing which settles down is bigger particles. Similarly, whenever rivers flow from the Himalayas, they would carry big boulders. They would carry big boulders, and it would be deposited at the foothills of Himalayas. That means closer to the Himalayas, big particles will get deposited. Why? Because if size is more, water cannot carry it. So what is going to happen? It will fall down. You see, the moment I have big particles, gaps will be more. Gaps will be more. Due to this, what happens? Big rivers may go above, but small rivers disappear. Small rivers disappear. So small streams disappear in this particular part. Okay, just below Himalayas, when rivers are flowing, big particles come and settle. And those particles, in between them, gaps are more. In these gaps, small streams disappear. Okay, so in this region, streams disappear. Second is, see, trees. Okay, trees. If they are present with less roots, okay, if roots are very less, it will be weak. If roots are more, it will be strong. Okay, if roots are more, it will be strong. If roots are less, it will be weak. So in this area, to maintain the strength, the tree roots will be deeper. To maintain the strength, the tree roots will be deeper. This region where you have big boulders is actually called as Bhabhar. Okay, it is called as Bhabhar or Bhabhar. Fine. So Bhabhar is actually present at the foothills of Himalayas, which almost is present from Punjab region to Assam region. See, Himalayas are there from Jammu Kashmir to Arunachal Pradesh. Okay, Himalayas are there from where to where? Jammu Kashmir to Arunachal Pradesh. So this region is also present from Punjab region till Assam region is. From Punjab till Assam, you will normally observe this particular thing. Fine. This is very important for us. Bhabhar. Okay. Now what happens is everyone think about it. Now immediately after that, what is going to happen? All small deposits will be there. Okay. Small deposits would be there. Now the small deposits which are there, In this region, all the streams which has disappeared will start reappearing. This. All the streams will start reappearing. It would be like sponge filled with water. This. Okay, sponge filled with water. That means if you take a sponge, you don't feel it's with water, but when you squeeze it, you get water. Similarly, in this region, particles are made up of fine grain. That means smaller particles. And the rivers which disappeared in Bhabhar region would reappear in this region. And the soil will be filled with water. As it is filled with water, good amount of trees grow in this area. So that area is very, very important for us, because as it has water, it is good for cultivation. So this region is called as Terai region. Okay, first region is called as Bhabhar, second region is called as Terai region. Okay, see guys, at the foothills of Himalayas, as the rivers will come, I'm considering only Himalayan rivers because Himalayas is made up of soft rocks and it is easy to break. Peninsula is made up of hard rocks and it is difficult to break. So due to this, what is going to happen? All big rocks get accumulated near the foothills of Himalayas, whereas small particles will be there little away from this. So this is basically called as Terai region, Bhabhar region. You see guys, next, let us say this is how the river meanders. Whenever the river meanders, as you are aware, river hits this part. As river hits this, it will break down. It will erode. It will erode. So, one side there will be erosion, other side there will be deposition. Okay guys, one side there will be erosion, other side there will be deposition. Now this is your river, okay? River 1, 2 and 3. Okay. So what happens is 3 will be old deposits. 3 will be old deposits. 1 will be new deposits. 1 will be new deposits. Okay. So 3 is called as old alluvial soil. 1 is called as new alluvial soil. Okay. And basically what happens, whenever water in the river increases, okay, please see here, whenever water in the river increases, 1 will be flooded. 1 will be flooded. 3 will not be flooded. So we say 1 is in the flood plain, 3 is not flooded. I repeat this, okay? Whenever river meanders, rivers will go and hit. So wherever the river hits, it will be erosion. Wherever the river slows down, it will be deposition. Closer to the river, new deposits will be there. Away from the river, old deposits would be there. Whenever there is flood, new deposits are affected, old deposits are not affected. Okay, so if I take this, you see here, this is my river, guys. Okay, this is my river. And this region, this region is my new alluvial soil. This region is my old alluvial soil. Old alluvial soil is known as Bangar. New alluvial soil is known as Khadar. Old alluvial soil is known as Bangar. New alluvial soil is known as Khadar. Okay. So same here. This is old alluvial soil, we call Banga. New alluvial soil, we call it as Khadar. Guys, remember, whenever river floods, river will have lot of sediments. All those sediments are deposited. Okay, so whenever in this area flooding occurs, sediments will be deposited, and that sediments will be very fertile. Okay, so if flooding occurs, fertility of the soil increases. And in this region, more flooding is observed in Khadar area. So Khadar is very fertile. Terai is also fertile, but extremely fertile is Khadar. Okay, you see guys. When I talk about alluvial soil in the Ganga basin, alluvial soil in the Ganga basin, it is divided into Bhabbar, Terai, Bangar, Khadar. Bangar is called as old alluvial soil, Khadar is called as new alluvial soil. One question you may get is, sir, river is still here, what happened to the river here? We cannot show 3D picture, guys. So if you look at Himalayas like this, okay, Ganga river flows down like this first. So you will have Bhabbar, you will have Terai, and then the Ganga river flows like this. And then the river flows like this. So I have shown Bhabbar, Terai, and here I will have Bangar, I will have Khadar. I will have Khadar, I will have Bangar. I will have Bangar, Khadar. Khadar, Bangar. Like this, the river flow will be there. That's why I have shown that, okay? So don't worry about the representation. What is required for you is alluvial soil, okay? So you write alluvial soil. I hope you wrote Gangetic Plains Delta. Here you write alluvial soil in Ganga Basin. Okay. I'll give you exactly 3 minutes, guys. Draw this. Yes, Kamal Pal. Hayat, no. Kadar is more productive. Ma'am, the person who updates it is on leave. Maybe that is the reason. Gully erosion के बाद you'll have ravines. Done, everyone? Yes, sir, Diti. Okay. Are these easy concepts, guys? Okay. Please write. Please write. Alluvial soil in Ganga basin is mostly deposited by rivers from Himalayas and peninsular plateau. Himalayas are made up of hard rock, sorry, soft rocks, soft sedimentary rocks, and are easy to erode compared to peninsular rivers which are made up of hard rocks. Compared to peninsular rivers which are made up of hard rocks. Hayat, uh, basically, yeah, yeah, peninsular plateau, sir. Hayat, basically, old alluvial soil in India is used a lot. Okay, old alluvial soil in India is used a lot. So, because of that, fertility has gone. So, whenever flooding occurs, the deposits will help in fertility. So, wherever floods are there, flood plains are there, you will have extremely high fertile soil. So this is what the concept is. If there is some misconception, you can get it clarified. So Himalayan rivers have more sedimentary deposits than peninsular rivers. No, no, guys. I'll have more classes tomorrow. Okay, I forgot to inform you. Because tomorrow also we will have class. Additional class will be there tomorrow. I think I have class till Wednesday, guys. And again, I'll take one more session if it is required. Okay. Even if I take additional classes, I'll ensure it is completed for you. Don't worry. Same time is tomorrow. No, no, Aditya, this is the exact one. Not beyond this. Sunday, no, it's only Saturday. Yeah, please write. Please write. Bhabar. Bhabar. It is present at the foothills of Himalayas. It is present at the foothills of Himalayas and extend from Punjab till Assam. Its thickness is 10 kilometer wide as it is made up of boulders. As it is made up of boulders, it would have more space and small streams disappear. Trees will have longer roots. Trees will have longer roots. Cultivation is difficult because big boulders are there. Cultivation is difficult. This is Babar. Second, Terai. Parallel to Babar, we observe Terai from Punjab till Assam. This region is made up of fine grain particles and pore space is very less. Pore space is very less. Due to this, the streams which disappear in Bhabar reappear in Terai. Evergreen forest may be present here. See, guys, as water will be there throughout the year, evergreen forest is there. Agriculture is predominant. Agriculture is predominant. That is Terai region. Bangar, old alluvial soil. It is present above flood plains and it is less flooded. It is present above floodplains and it is less flooded. Whenever fertilizers are used more, the fertility of soil reduces and it would become alkaline, called kankar, usar, reh, or color. See guys, not so fertile soils are called as kankar, usar, reh, and color, and they are basically part of what we call as, like, Bangar. Last, you have Khadar. It is new alluvial soil present in the floodplains and it is flooded regularly. Minerals are added and is fertile. Minerals are added and is fertile. See guys, this is basically Anjali. I didn't understand Anjali. Himalayas have soft rocks. Not like that, Anjali. The problem is you're not understanding the soft and hard right from the beginning. See, how are sedimentary rocks formed? Sedimentary rocks are formed because of, like, deposit by the rivers into the lakes. Okay. So how does the deposit occur? As I told you, layer after layer will be formed. Okay, so as they are in layers, basically it will be like limestone, sandstone, and all. So if I rub it, easy to separate them. Okay, easy to separate. So that's why it is called soft rocks. And when I separate, everything will not be of small size. Different sized particles will come. So bigger particles will first get accumulated. That is called as bubble. Okay. Okay, guys. Tomorrow at 5 p.m. we'll have the class. And guys, if at all you need more details, you can follow me on Telegram as well. It is Sandeep Mahajan, double N. 5 p.m. to 8 p.m. Same classes. Okay. No, no, ma'am. Telegram ID, ma'am. Thank you, guys.